Okay, so here we are, Chapter 7, lesson, I don't know what number it is because I haven't done the first part of this. But this is the second part from day 2. Okay, so now what we're going to do is, oh, you know what, here's the question we have. Are any of these values outliers? Are any of these SAT scores outliers? How do we determine an outlier? Well, there are 2 ways we can determine an outlier. First thing that we could do is that we could find Q3 and Q1, subtract Q3 minus Q1, find the interquartile range, multiply by 1.5, take that value, which we nicknamed Steve, take that value, add it to Q3, build the upper fence, sorry, this side, build the upper fence, subtract it from Q1, build the lower fence, excuse me, and then what we're going to do, scratch, is see are any values outside those values. And I don't know. That's a lot of work. That's more work that I want to do. The other thing that we said that we could do is instead, because when we looked at that, it was Q3 and Q1, and those values ended up to be somewhere around 2.6 something standard deviation from the mean. So we said anything beyond 3 standard deviations from the mean would be considered an outlier. And that would put it in the top 0.15% or the bottom 0.15%. And if you're up there, you know that you are unique. So what we could do is say, hey, if it's beyond 3 standard deviations, that means it has to have a z-score of above 3 or below 3. So we can scroll through this list right here and say, do we have any outliers? And the answer is, we don't. There are no outliers in this group. And that's good information for us. Okay, so now what we're going to do is we're going to go to L4, and in L4, we're going to, as I scroll to the top of L4, really, I'm going to get there. As we get to the top of L4, we're going to take the freshman year GPA and we're going to turn them into z-scores as well. Again, using the formula, as I put a dot right there, using the formula, x of I minus the mean over the standard deviation. But this time we're going to do it for freshman year GPA. But we have a problem. And the problem consists of x bar is right now 1,057 because it's a variable and it's 1,057.33. That certainly is not the mean of the freshman year GPA. So what we need to do is we need to reassign x bar and standard deviation, S sub x, so they would be the mean of standard deviation for the freshman year GPA. Can we do that? Certainly, it would not be hard. All we have to do on the calculator is one variable stat for, in this situation, L2, and that would reassign those values. Okay, not hard. Stat, calculate, one variable stats for, and we have to be very specific that we put in L2, even though the default is L1, now we're not using the L1 list. For L2, and we get a mean freshman year GPA of 2.69, standard deviation of 0.69. And if we think about this, this makes a lot of sense that the standard deviation is so much smaller than 243, because if we think about the scale of freshman year GPA, scale of GPA is from 0 to 4. So of course we're going to have a standard deviation much, much smaller because the axis is going to be much, much smaller. Okay, so now we can actually use x of I minus the mean over the standard deviation and convert all the freshman year GPAs into z-scores. So we'll do that again, stat, edit, we will go to L4 in the menu, the exact same thing that we did last time. Start with a parenthesis. X of I, our raw data, our values of interest, happen to be, however, in L2 because that's where the freshman year GPA is, minus the mean. Again, it's a variable, it's a statistical variable, it's number 2, x bar, close a parenthesis, divide by, standard deviation, it's a variable, it's a statistical variable, it's number 3. Trying to look at the camera here so it doesn't look really weird. I hit enter and here we are. Okay, freshman year GPA, first person 3.25. It's above the mean of 2.67. How far above the mean? 0.80709 standard deviations above the mean. 2.51, a little bit below the mean of 2.67, 0.2645 standard deviations below the mean because it's negative. Do we have any outliers? Anything above 3 or below 3 would be an outlier. I'll let you look. The lowest value was 1.55, and it's not. So we have no outliers. Okay, so now what we're going to do is we're going to graph Z. So we'll go to second, we'll go to stat plot again, and we're going to plot, this time we're going to plot the Z-scores. Again, we're going to assume that freshman year GPA is dependent or influenced or determined by SAT scores. So SAT is going to be the explanatory variable, freshman year GPA is going to be the response variable, and those happen to be in L3 and L4. Scale's all messed up because now we're looking at something, we're looking at Z-scores, so we're looking at -3 to positive, -3 to positive 3, and -3 to positive 3, as opposed to those SAT scores, which are in the thousands, completely different. So again, we have to zoom 9. So we zoom 9 and we get this graph. Now, here's what we notice. Grab this graph. Is it coming over? It looks like it is. And those graphs are the same. They are the same. Now, I could expect them, as I get the pen out of the way, I could expect them to maybe be a little bit different simply because if the scale compresses a little bit, the graph might tighten up, but it's not going to tighten up a whole lot. It still should be generally the same shape. And they are. They are generally the same shape. But now we need to talk about something really important, and that is this right here. My pen's off a little bit, but that's this right here. Right here, dead center is the origin on our graph because this is in Z-scores, and here we are. There is 0, and there on Y is 0. It's the origin. It's the point 0, 0. But what does that represent besides being the origin? I mean, there has to be a reason that it's there. And if we think about what 0 means along the x-axis, 0 on the x-axis is the mean. It would be x bar. Yeah, it would. And as we're thinking about y, along y here, it's also going to be the mean. So what this point represents is it represents the mean of x and the mean of y. So how would I write that as a point? Because if I write a point in space, it is the point xy. But now what we're talking about is we're talking about the mean of x and the mean of y. And the way that we say this is that that is the point x bar, y bar. That's the mean point. You call it M-E-A-N dash M-E-A-N, M-E-A-N comma, M-E-A-N. It's the mean point. And it's a very important point, and we will see in chapter 8, and we're going to use this point to more of our benefit. But for right now, it's called the mean point. And what we're going to do is we're going to go here to fathom. You know what? I don't want this. That's the salaries and teams. So we're going to close that, and we're going to cheat here, and we're going to open up this exact same data in the Fathom program, because the Fathom program happens to be very helpful for us as we wait for this really slow computer to do this. Okay, so here's SAT and freshman year GPA in the Fathom program. And I'll minimize this for a second. Come on, Fathom. Or don't. Nope, there we are. And if you're a regular in my classroom, instead of someone just watching this, and why you would watch this that you're not in my classroom, I don't know. But if you're regular in my classroom, you realize that we have technical difficulties all the time. Yeah. But we're not going to try and film around. All right, so here's our graph. Here's our SAT. Here's our freshman year GPA. And there's the graph. And we're going to expand this graph a little bit, and we'll bring it here. I also have the data set up for Z-scores. So I'm going to create another graph. Here's the graph for Z-scores, and Z-scores SAT versus Z-score GPA. And the graphs are the same. And here is the mean point. Now, here's what we're going to look at. As we look at the mean point, and let me bring this thing back up here, and we'll draw on the graph itself, attempting to. There we are. Okay. The mean point, the mean for the x, was 1,057. So here's 1,050, 1,150, there's 1,100, 1,057, 60, right about there would be my guess.